Hello and welcome to Physics 101, the premier class on, you guessed it, physics. Today, we'll cover Newton's 3 laws of motion. The first law of motion is, an object will stay at rest unless acted upon by a force, and that object will continue at a constant velocity unless acted upon by another force. For those who don't already know, velocity is speed plus direction. For a good example of velocity, we'll use this Super Smash Bros. Club. The Ganondorf is launched up and left, that's his direction. And the speed at which he travels, according to my estimation, is about 24 feet in 6 seconds. If we simplify 24 over 6, we get 4 feet per second. So the correct syntax for this poor Ganon's velocity would be 4 feet per second up left. To portray Newton's first law, we'll use a rod, some balls, and a hole. This example may get a little spicy, so if you can't take the heat, skip to the timestamp in the description below. 3, 2, 1. Alright, let's talk about golf. When the ball is hit, the club is applying force to the golf ball, but because of friction and wind resistance, the ball will slow down, changing the speed part of velocity. Finally, it will go into the hole due to gravity, changing the directional part of it as well. Newton's second law is that the acceleration, how much an object's speed increases, depends on the mass of an object and the force applied to it. The mass is how much space an object takes up and how dense or compact the things that are in it are, whether that be matter or in any way, shape, or form. Mass is a bit tricky, so I'll show you a model. Take for instance this cup. Let's say it's 5 by 5 by 10. Right now, the thing inside of it is water, which is not very dense. But if we pour the blood into it and call it one single object, you could say that the mass has increased, since blood is thicker than water. Though there are smart people on both sides of that debate. Now that we're done explaining mass, we can hop right into Newton's second law. On the left is a guy who looks like he was ripped right from the front page of NN. Let's call him Sean. On the right, we have a guy who looks like he was doing unspeakable things whilst looking at the front page of NN. Let's call him Dan. No matter how much you push on Sean, he'll never budge. He's just that massive. He takes up a lot of space and is very dense. Our force is no match for his massiveness, and he will not accelerate. On the other hand, if we so much as flick in Dan's general direction, he'll go flying. He doesn't take up all that much space, and is not as dense. Our force blows his massiveness out of the water, making him accelerate a lot. Lastly, Newton's third law states, for every force there is an equal force in the opposite direction. This law doesn't have any vocab I need to go over, since it uses second grade vocabulary to describe itself, so that's a bonus. For this last example, we'll be using a solid hypothetical. Let's say a man punches a baby so hard it goes flying into the stratosphere. Would you say this person is a terrible human being who should be charged for murder? Well, let's look at Newton's third law for the answer. The force exerted by the puncher is also being exerted to him as well, since he's hitting the baby's face. The force of the punch is met by an equal force in the opposite direction, to himself. Due to Newton's third law, we know that the puncher is experiencing the same amount of force as the baby is. We don't see anyone locking up the baby now, do we? I'll leave it at that. Well, I hope you were able to learn something from this video. Tell me in the comments below, or in the iCard poll, in the iCard, obviously, whether you think the baby puncher was in the right or not. Now, if you'll excuse me, I've got to go finish the homework that was due 3 weeks ago. Bye-bye.